Now we are in the last session for the first day. Now we will have lectures and also a tutorial of introduction to Python from Dr. Norhasliza Yusof. We'll read about her CV first. She got a PhD in theoretical nuclear astrophysics from University of Malaya. Now she is the senior lecturer in Department of Physics, University of Malaya. Her area of research is computational physics, especially numerical techniques, astrophysics, about stellar evolution, and especially about very massive stars. If you're interested in very massive star, mass with few tens until 100 solar mass, so you can discuss with her. And also about nuclear astrophysics, theoretical nuclear astrophysics. Okay, Lisa, your time and this to this session.
All
Please.
right, thank you, Iqbal. Okay, so good afternoon, everyone. Thank you, Iqbal, for giving me a nice introduction for for our first session today. So, like Iqbal mentioned just now, I am a astrophysicist, so I'm not an astronomer. Okay, so but I'm glad that what they call it, the committee called me here to share my experience in what we call it in introduce you Python. I'm sure that most of you from the what they call it, the survey that I received, half of you already very good in programming, and then another half of you are still looking forward in how to learn Python. Is it right? So because we try to do a bit two-way interaction, because this is afternoon, right? So maybe some of you might be a bit tired or a bit what they call sleepy after lunch. So we try to have more two-way interaction rather than one way. So then after that, after I've given my lecture, you can go to your own group, and after that we shall do some hands-on according based on the lecture that I give to you. Okay.
Okay,
So,
one more. If there's any question, can the participants stop
yes,
during your
yeah.
lecture?
So
Okay.
if the student have
Time.
any question, or you want to know in details how to the one that I explained, so please interrupt me, no problem. So I'm going to explain to you bit by bit. And one thing I have to mention, this course is designed by assuming everyone don't really have what they call it the basic of programming, because I'm trying to cater for all of you, so that no one of the student will miss how to deal with Python. And after that, we will work on some exercise, and from there you will try to understand how the flow of Python. So if you have experience in doing programming, it should be quite easy to understand. Okay, so let me share my screen here. All right, so I hope I'm doing PDF here because this was in a keynote, so I hope that the page will be good enough for all of you to see. Okay, so all the notes and also the code is available in this GitHub page. So I guess that all of you have experience doing GitHub? Yes, no? Or you don't know? Anyone?
Yes, I have. No?
Yes, ma'am.
Yes, ma'am.
Yes.
Yeah.
Okay, that's great. Okay, so there is two ways to take what they call code via GitHub. Either you can clone the repository, or you can just using the very nice way, you just click and download the code. Okay, so don't worry about how difficult to download, to clone it, unless you are on the Linux machine or in a Mac machine. It's easy for you to clone it. But if you on the Windows machine, just click and download, right? So it will be a very straightforward process. Okay, and this what they call lecture is adapted from two courses that we have taught in Universiti Malaya for quite 5 years. Okay, so we introduced a bit of Python, and currently we use Python 3. Right, so I think most of you already installed Python or already available the Python in your machine. So let's go and see how does this Python work. Okay. All right. So the basic info before we start in understanding the Python, what they call it, language itself is you have to have a Python 3 installed in your computer. And usually to learn scientific computing or machine learning is something that come later on. Usually people learn about scientific computing first before you learn machine learning, because machine learning is actually the application of scientific computing, right? So you need three major things usually. You need what we call it a matplotlib. Oh, I forgot to put pandas. Matplotlib is for visualization. NumPy, a numerical Python. SciPy. SciPy is where all the scientific computing library is being dumped, but it's still being handled by NumPy for certain what they call it libraries. Okay, so it's if you import SciPy, you have to import NumPy also. For example, if you want to handle arrays. Okay, and then this is additional Seaborn, PyTorch, TensorFlow. I'm sure that you have downloaded or installed last night, and I can see that many of you are still trying to figure out, because one thing in Python, there are two ways to install it. Okay, so one is if you use python.org. This is if you install by using Linux distro or Mac OS using terminal. So if you use terminals in your Linux or in your Mac OS, you have to call by using pip, right? So pip install Python 3, whatever, and it will install directly to your computer, and it was called from this python.org repo. So another popular, what they call it, package has been what they call used is anaconda.com. And then we have another one quite recently people use it is in PyCharm. So in industry, currently many people try to use PyCharm, what they call it, IDE, because it's easier to handle. And I think the size is a bit lesser than Anaconda. Okay, so these three things, okay, so if you use Python, it will, what we call it, one thing's advantage and disadvantage in using Python Anaconda. If you download directly from Python, what happens is all the packages, matplotlib, what I call NumPy, pandas, and so on, need to be downloaded separately. Okay, so this is one thing. If you are good in programming, this should be a very straightforward process. So if you are novice, you are a beginner in using Python, I would recommend Anaconda. But Anaconda, one thing you have to bear in mind, you have to check the size of your machine first before you install Anaconda. Usually in server base, we use what they call it, python.org for or pip install. But Conda command will give you a Conda install. So these are two things. Anaconda.com is good because it embedded almost all library that you needed in one click. Okay, so when you try to download Anaconda, it will download almost everything from Matplotlib, NumPy, SciPy, even Astropy, and also all the library. The image is being downloaded to your computer. So if you have a small computer, it can crash your machine. So there is one thing that you have to carefully install. So if you have a small machine or you have problem, you can use Miniconda. That is another alternative of Anaconda, right? Okay, so this is the additional remarks. I think that some of you already know, or maybe some of you don't know. Okay, so this is the idea of how there's the difference between all those repo calling the Python in your machine. Okay, so this is quite what they call just some basic info why you should know all those the different things to install Python. Okay, so sometimes when you install in Linux, you pip install Python, and then when you start to write your code and you run it, and it will complain, say that this package is not available or there is error. It means that some packages are broken or not installed properly. Okay, so this is one thing you have to bear in mind. Okay, so Anaconda installation is available in almost all OS. Okay, so that's why you have to see that what is the size of installer itself. Currently, it's already 3.9, Python 3.9. And if you install packages, you have to check what are the current version of your Python. If you don't, what they call it, the version is not matched, so the packages cannot be embedded. Okay, so for example, last night, some student unable to install TensorFlow, right? Because I suspect that the version of Anaconda Python in your computer is not matched with your TensorFlow. It's either you have to upgrade it or downgrade it depending what are the version of TensorFlow that you want to install. Okay, so there is one thing that you have to bear in mind, right? So if you don't have, okay, so this is how it look like if in Windows. Why I show this one? Because I've been taught undergraduate for quite some times, and most undergraduate use Windows machine. Okay, so when Windows machine, they don't really have knowledge in how to deal with terminals. Okay, so here I show you the basic. I think the current one, they have more. This is quite old one. So we have Jupyter Book and Jupyter Lab. Okay, this is the interactive one. And another one is IPython. And if you want to have a conventional ways to write a code by using compiler and debugger, we have what we call SS Spider. Okay, so you can use, for example, Visual Studio as well to run your code. If you are installed in your Windows computer, it can call easily, right? So you might see that we have Jupyter Lab and Jupyter Notebook. What are different? Okay, so Jupyter Lab have more what they call application. For example, if you want to jump to a folder, Jupyter Lab give you more power or interaction to jump to the folder, but not in Jupyter Notebook. Jupyter Notebook, you have to, what we call it, to open again if you put your code in different directory. Okay, so you will see later on how it looks like when you start to work on it. Okay, so for today, I'm going to introduce you by using a Jupyter Notebook, which is quite simple for people who want to start learn Python. Okay, so if you don't have machine, you have problem, you don't know what happened. So what is another solution to use Python without to deal with all this installation problem? So you can use Google Colapse. Okay, so Google Colapse, if you have a Gmail account, you can use it freely, and I think it allocated you around 1 terabyte of what they call it disk, free cloud disk for you to run the code. But bear in mind, it needs you to have a stable internet connection, and also it depends on the what we call it the traffic during that time. Sometimes if you want to process huge data, the traffic can be slow, and then it will take some time to execute your code. Okay, so this is one thing that you have to bear in mind if you want to use Google Colapse. And one thing that maybe I don't know whether you know or not, Google Colapse is being optimized in Chrome. Okay, so this is I figure out when I teach a student. If you have several browser, Safari, Firefox, Chrome, and what is the current Edge or something like that. So the most optimized browser will be Chrome. If you want to, and Google Colapse can be run by using your smartphone. Okay, so last time when we start off pandemic, some students don't have any laptop because you can go to the department and use your computer lab, right? So when we start this COVID pandemic, we have to go back home. The students have to go back to their hometown, and some of them don't have a notebook. So I figure out how the student can write the code by using smartphone. Okay, so you can install Google Colab in your smartphone, but you have to install Chrome browser. Okay, so this is the trick of how you want to use in a smartphone. So you have to install Chrome browser in your smartphone and also your Google Drive. Okay, so why you need these two things? Because all the file, for example, external file that we read or file that we want to save later on, will relocated to your Google Drive. Okay, and one thing is you have to sign up your Gmail, right? So because when you sign your Gmail, it will allocate you where is your Google Drive and also the Google Colab. Google Colab is just like interface for you to write all your code, and after that, it will be saved in your Google Drive later on. Okay, so this is one things that we figure out how to do it in many ways. Okay, so not only by you have a machine, you have a server, you have what you call browser, and also you can use when you have a smartphone. Okay, so this way we have to rethink of teaching during this pandemic, right? So if so friends from other country, so we are in Malaysia, we are still in the lockdown, meaning that all of us are still stay at home. I guess that even our coming semester, we still what are we going to do the online class for the next semester. So it will be almost 2 years we are stay at home and not able to go anywhere. Okay, so here that's why you have to think a bit on how to deal with this in teaching. Okay, so I'm going to introduce you what are the introduction to Python. If anyone have any question, please ask. Doesn't matter, especially for those who don't have any experience or still in beginning level. So don't be shy. Don't be intimidated by your friend or other participant that do have more experience in programming, because this is what we call it the place that you want to learn or you have to add on your knowledge. Yeah? So I will answer whatever question that you want to ask. So there is no such thing as a stupid question. So just ask if you want to know anything. Okay, so if you have what you call experience in Python, so usually in Python or in programming, we have to assign number or value by assigning by a variable. Okay, so for example, A equivalent to 10 or B equivalent to 100. So this is how we assign the variable. But one thing I learned in Python, because I used a lot of Fortran for my research, because I do a stellar evolution. All the stellar evolution code is written in Fortran. Okay, so in Fortran we deal a lot of assigned by a variable. But when I discovered Python 10 years ago, when I do my PhD, I found that if you use interactive Python, this step can be skipped. But if you want to write in the script form means that you want to write your code in Python and then you want to run through the remote computer. For example, you are here and your computer is in your university, you are at home and your computer is university. It is faster for you to run your code in a script form rather than interactive. So it will reduce the what they call the speed or the time or the data crunching if you need to do it. Okay, so this is if coming from experience, if you do a lot of programming, you will see what a difference. Okay, and in Python, numbers or value can be either integer or real. But in Python 3, all numbers are considered real unless we set it into integer. Okay, so this is another thing. If you learn programming or programming language other than Python, for example, Fortran or C, this you have to assign what are your numbers. Okay, so you have to assign either is integer or is real. Why this thing is important? Because if your number is integer only, when you do mathematical operation, there will be what we call it as a truncation error. Okay, so truncation error, for example, you want to divide 1/2, right? So 0.5. So in integer, you will see as 0, not 1.5. So this is one thing that we have to deal about the scientific computing. But in Python, whenever value that you put, it will see as a real value or real number. It doesn't care unless you say that your numbers is integer, then it will treat it as integer. So this what problem has been skipped one step more compared to other programming language. Okay, and in Python it also can handle complex number. And if you learn maths in I don't know in astronomy how it, but I teach in a physics department. So in physics we always assign our complex number as I, right? But in Python they assign complex number as J. So this is one thing that also we have to carefully when you write a code. So the different interpretation for different language also is one of the concern if you start to deal with the complex number. I'm not sure whether in observation astronomy you use a lot of complex number, but if you what they call it, deal with the what we call it in physics, we deal a lot of complex number, especially if you do some numerical calculation, right? And Python can handle these three type of numbers, either integer, real number, or complex number. And to produce output on your screen is just you have to use command print. Okay, so this is a common things that in Python you have to do print. But I think if you learn in your Jupyter notebook, some of the what they call it, command can be skipped. Again, it depends on what is your variable. So if you are being trained by using interactive Python, and after that you have to move to a script, there are several things that you have to understand and what are the what they call it, the constraint. Why I say this? Because for example, when we teach students using interactive Python and they do some calculation and it was appear the output immediately without putting additional command. Okay, so for example, print and also show for the matplotlib. Okay, so this in interactive Python, this has been skipped, the command, but not in script. If you have to write in script, you have to put additional command so that when you run the code, it will give you the result that you needed. Okay, so this is one thing, right? Okay, so this is a syntax of introduction to Python. One thing that when you open a Jupyter notebook, and this is I'm taking the screenshot from Jupyter notebook. Okay, so Jupyter notebook do have two type of what they call it, how you want to write in the cell, right? So you can see that the cell here, the one that without number, this is called as a markdown. It means that you can write a text for your word instruction. Besides this, if you write in the script, usually we put, this is what we call as a comment, this hashtag here. So this is a comment, means that anything that you write in your code is not being read by the what they call it, the compiler. Okay, so here I put some basic print statement. Okay, so I say that print, hello, welcome to Statistics and Machine Learning School. So when you press enter, it is immediately will give you this output. Okay, the normal programming language command will be hello world. So I'm going to try to make it a bit different instead of a boring hello world. So we make it a bit more related to our school here. Okay, so then I'm going to show you how we can assign some value. Okay, so this is what I meant by assign of a variable. Okay, so for example, this is our variable A and B. So we have to assign what are the value of the, what they call it, even to assign, for example, A for certain value and B of certain value. After you print the output, you can see that A and B is being represented by the value that we have assigned before. Okay, so this is, if you print like this, it means that you're going to print line by line. You have to remember when you learn about coding, it always read from top to bottom. Okay, and it's read from left to right. Okay, so this is this left to right. So if when it read left to right, so you have to know the flow of the code. This is how we what they call it learn how to code. So one thing I always mention to my undergraduate student, the code is not clever. You are the clever one. We are the intelligent person. That's why we call as artificial intelligence. All these things are artificial. The real intelligence is coming from human, right? So this is one thing that people have to aware. No matter how good the artificial intelligence is, the brain is still coming from the human itself. And the bias is still coming from the human because it depends how that you write the code, right? So it depends if I write the code, or the bias will come from me. If you are the one who write the code, the bias will come from you. Okay? It's a matter of preference of individual. Okay, so this is one thing that I always mention to my student. You are the clever one, so you tell the computer what you want, not the other way around. Okay, so this is how you learn how to code. Right. Oops, sorry. My cat is trying to make the environment more interesting. Okay, so and if you can see that we print A and B, it means that I print from line to line. So if you put a comma here, it will print your output side by side. Okay, so this is the way of how we what they call it write our code. So if you put this mark here, so instead of putting it produce numbers, now it print the character itself. Can you see the difference, right? So I think most of you have learned coding. This is quite straightforward, what they call it information. And you also can assign what are the type of object in Python. So for example, you have 3 types of object, integer, floating number, or complex number. You can assign like this. And then when you print the type, it will give you the class of your printing. So one thing that, for example, if you do mathematical operation, some square 1 over square root of something, sometimes your number will end up as a complex number. So you can see that your answer will something appear as a J. I have discovered for the other language, they don't really do like this previously, but now it evolved. So you can see that if you have some different way of writing code, it will give you the answer that you want to know. So one thing when you write a code, always check your output. These are the most basic thing that you have to understand when you write a code. You might have a fancy code people have wrote very nicely, but does it will cater your needs? This is one thing that you have to ask yourself. Okay, so when I write the code, for example, install evolution, well, we have a huge people who are contributing for the subroutine. So when we want to match with our the output from one point to another point and merge together, we have to check is the input that people produce, okay, so the output that people produce to being used as our input must be matched. For example, the type of the data, is the value is correct or something like that. You have to check. Okay, so if you don't check your input, probably your answer will be wrong. So this is how you learn how to code. This is similar to any language. Okay, so the can be implemented in any language. All right, so this is a basic mathematical operation. So in Python, similar to other language, it will complement what we call as a series. Okay, so you follow what we call it the parentheses, exponential, and also the mathematical operation, right? So this is the basic example. I think most of you might already see, but it might be a bit different. For example, power. Okay, so if you use MATLAB, I think, or either language, some of them put the string, right? I mean this what you call the triangle, right? So here in Power, Python they use this double star. Okay. So any questions so far? Or people still can follow my lecture? Okay. So there's no question so far. Let me go through. So we have some mathematical operation on dealing with the some what they call it value that we want to calculate. Okay, so when we deal with, for example, astrostatistics, I know that you deal with a lot of arrays. Arrays means that what are the dimensional of arrays that you want to run. So previously in Python 2, this is from my experience running Python 2 15 years ago. In Python 2, they don't have any, what they call it, when it start to release the Python during that time, to call an array is a mess. Okay, so you have to assign dictionary and then you have to read everything, what they call it, like a bash script. I don't know whether you know bash script or not. So you have to read everything. You have to write a very long subroutine just to read an array. But now we have NumPy. NumPy save your life totally. I can see that now dealing array in Python is no longer messy compared to 15 years ago, right? So last time when you have to call, for example, you have 100 by 100 arrays, for example. To read them one by one is you have to assign all the variable to read every, because Python reads a column, so it don't read rows. This is one things that I discovered in Python. So it read what they call it it read by row by row, right? So they don't read column like Fortran. So Fortran if column 1, column 2, column 3, right? So here they read by rows. So when you read this, sometimes when the data is missing, it will start to give some weird number. Okay, so this is one thing that, but now it's no longer you can easily detect, and it will give you error if there is some what I call weird number in your table or in your data. Okay, so here we have to call array, and now array must be used. We must use a library called NumPy. Okay, so for those who have never learned program or Python before, usually this is a favorite things people always say. We import NumPy as NP. This is a short form. Okay, so import NumPy as NP, import pandas as PD, and import matplotlib as PLT or NPL, depending on your preference. Okay, these are the three things that always people use when dealing with Python. Okay, so when we import NumPy, you can see that we can assign our variable as what we call as an array, and you can see that in array, not only we have to deal with the bracket, and we have also these square brackets, meaning that these are the array containing of our value. Okay, so when we want to test our array, so we can see that, for example, if you want to test the summation of our A and B array, and when we do the, for example, a summation array, you can see that it will sum according like a matrix rule. Okay, and also when you test for multiplication, it just multiply all the value according to each, what they call it, each value here. It will read 1, 2, 3. Okay, so this is how what they call it, Python read. And one thing, especially if you want to create data, one what we call it important command is we can create a zero matrix. Okay, so it depends on what are your calculation. For example, if you want to do some what they call it, linear analysis. So this is you have linear equation, you want to solve it. So usually we have to assign our matrices as zero matrix, and then we put the number later on. It depends on how you deal with the linear matrix. Okay, so and linear matrix, if you find zero, is just created some zero matrix of 5, 0. And then if you want to have a shape of 2 by 2, so now you can have NumPy 0, 2 by 2, and you have this 2 by 2 matrices. Okay, and all standard matrix operation can be used by the dot matrix, and then you can have this matrix operation. Okay, so this is being called by NumPy. So one thing I forgot to mention, in Python, everything is start from 0. Okay, automatically, right? So unlike if you deal with some data, for example, you have 100 data, so it will count 0 until 99. It's not 1 until 100. Okay. Right. So In what we call it in Python, we have several mathematical functions. So this is I just choose a few that usually people use in astronomy. We have log, log2, log10, and all those trigonometry, pi, square root, truncation, exponential array, and degree must be called by the NumPy. All right. So one thing that you have to remember in Python, all the value, if you work in a trigonometry, you are in radian. So it's not in degree. So if usually in other language, all the value are in degree, but not in Python. It's automatically calculated in radian. So if you want to have your answer in degree, you have to what you call transform it. Okay, so you have to write a bit short code, and then you have to transform the what they call it your calculation. Okay, so next, already half an hour here. Okay, so we also have loop here. Okay, so in Python we use for loop. Okay, so you can see that one things I like in Python, when you write for loop, when you press enter immediately, it will give you indentation, but not in other language. Other language you have to count, if I'm not mistaken. Okay, it don't give you the automatic indentation, right? So when you put this for loop, for example, we want to iterate I 10 times, okay, and then we can print what is the value of I. So from here we can see that the I start from 0. This is what I mentioned before. In Python, everything is start from 0. So if you want to start with 1, you have to assign what is your I, the first one. Okay, so this is, you have a 0, but all are 10 values. Okay, and after that, if you want to constrain your loops, you can put this, for example, 2 and 5, but still because it start from 0, it will stop at 4. Okay, because of the how they count the number. Okay, so another, another what they call it, a loop that usually we use in Python or in scientific calculation is we use a while. While is especially if you have a condition to fulfill. For example, we have, for example, if I less than 10, we want to do this mathematical operation, then we can print the result. You can see that now it start from 1 because of due to the mathematical operation. Okay, so if I equivalent to 0, while I less than 10, then you will do this operation. Or they say, okay, is I less than 10? They say that I is 0. Yes, correct. So it fulfill the condition, and then it start to do this operation and print all those results. Okay. And I already mentioned this before, but this is, I think this is duplicate from previous one, I guess. It's okay. I skipped this one, the array. This is just the same just now. And another things that we use a lot is what we call as a user-defined function. In other language, we call as a subroutine, but in Python, it's just called as a user-defined function or function. If you learn other languages, it will say that either what we call it subroutine or what they call it function. Okay, so in Python, only one thing they call as a user-defined function, but it can be, but the usage is more expanded by compared to other languages. Okay, so for example, we want to write a user-defined function for this what they call it equation. Now we have function of f or function of x equivalent to 3x power 2 plus x plus 4. This is what they call it some a polynomial function, and from there we can the what called the name to call the user-defined function is given by def. Okay, so this later on you can when you do for other exercises later on for other lecture, you will see that how they expand the usage of this user-defined function. So here I just give you a very simple example. We want to define a function in terms of x. So return of all this formulation. You can see that how I wrote the formulation. X power 2 plus 4 plus x plus 4. Okay, and then we can say that what is our our value of x. So we put what is x, and then we print the function, and it will do the calculation for you. Okay. So if you want to make it easier, instead of you define like this, you can put directly like this. So why, if you see that sometimes people do a huge computational work, we put like this because sometimes we want to change our x, right? So we want to vary our x, so we can do like this, or we can do in terms of loop. Okay, so I think this is the few last point for this slide. Okay, so here we want to make a plotting. Okay, so just now we have seen how to do basic operation, how to deal with arrays, and then for the loop. And now we move on to the visualization or making plots. Okay, so one thing that the most important, I think the first thing people use Python is to making plots for publication. This is also how I discover Python, right? So because it can do a nice vector image. Okay, so that's why Python came to. I think one of the early module or library is actually Matplotlib. Okay, so Matplotlib is one of the popular library, and it's been evolved quite a lot, and it can handle multiple library. Okay, so here, when we want to use Matplotlib, we can import it as a PLT to import the library. And if you deal with some value that needs to deal with the, for example, trigonometry, for example, you have to import NumPy. Okay, so from here, you can see that I want to have a range of x from 0 until 10, 0 until 10. And then we have a step size. This is what we call a step size. Step size means that every point, 0 until 10, is being from 0, 0.1 until 10. It will move as a step size. And then from there, x is going to be used as an input for the sign function. So why is NumPy sign? It means that now where is your x, and it's being called by all this value. So you can assign all this value, and then from there we can get this plot. So because I want to make it a more, what they call it, feasible for us to see that we have to label it and see that what are the things. So to label it, you can call as an X label or Y label. It depends on your preference. If you have more, what we call it, specific label, you can change it here. Okay, so the one that I've shown you, PLT plot, is it will plot what we call it a straight, I mean the line like this, the straight line. Okay, so if you want to, if I know some of you might be more advanced in Python, they have some what called options is scattered and so on. So because I've learned Python quite conservative way, okay, so there is you can either put like this and then assign the marker later on, or you can directly put, for example, MPL scatter or something to get the different way of plotting. You can play around after this with your tutors. Okay, they will help you in understanding more. But this one is, I just show you the simplest way to write or to making plots. Okay. Right. So if you have to plot a few functions, for example, you have to assign your variable differently. From here, I want to plot sine and cos in one graph. So I just assign different value for another y. I put it z, and then I plot it x and y for sine, and z, x and z is for cos. So you can have a nice two plots in one graph. There is another way to do it. There is more, what they call it, more specific or more professional way to do it. But this is, I show you the easiest, or the what they call it, the easiest way. For example, if you want just to check your data. Okay, so in order for you to show the legend, you just call PLT legend, and then it will show. If you write in script, so script means that your file, the extension will be .py. All this file is in what they call extension of IPYNB, the Python Jupyter Notebook. So if you write in traditional script .py, you have to add one more command, what we call it PLT.show in bracket. It will produce the it will show you the result. Okay, so that is if you run in the script. If a Jupyter notebook, you don't have to worry about this. Okay. Okay, so all codes are available in my GitHub. You can try to take it from there. Okay, so I stop share here. Any questions so far? It's already 2:25. I haven't mentioned to the data yet.
Yes.
Any questions
Yes,
so far?
any question? Please raise hand. Yeah, Aston, please.
Okay, yes.
Thank you for the time given to me. I would like to I have a question. How about when we plot graph with differential vertical value? When
Vertical
you
value.
yes.
So you mean the function itself?
Yes, the function is the same, but we have different value of vertical. So we plot same horizontal value, but different vertical with two graph. How about that?
You mean that you have a equation, theoretical equation, and then you want to compare with the, let me understand your question correctly.
I'm sorry. In the last example, you plot two graph with with one x value and one y value. How about when we plot one x value and two y value?
And to y value mean?
Yes.
Maybe I want to help Aston about this question.
Okay.
As I understood that Aston asked you about how to show on the plot about if we want to show about the different scale in y-axis.
Oh, you mean that you have two y-axis, isn't it?
Yes. So in different scale.
Oh, okay. Yeah, all right. So now I understand the question. Okay, so if you have what they call it, two different y value, so you have to do a bit more what we call it command, right? So in this case, when I put this PLT plot, it means that we only assign one frame. One frame, it means that all the data is coming in one frame, right? So if you want to have another y-axis, for example, or another x-axis, for example, right? So if you want to have two different x and y, this one we have this y here and x here. So we have to create another frame. I don't show it here. Right? So we want to create frame. So what you should do is instead of using this very naive what they call it way to PLT plot, so we have to add another one, what we call as we have to assign a figure, comma ax, and then we have to do subplot, right? So when you do some subplot, and after that your frame, you have two frame now. Okay, so when you have two frame, then it won't share. You have to plot it again by assigning either you want to have frame 1 and frame 2. So for example, you have here, I just put some example. You have to put your ax, your axis 1, another one you have to put ax2, for example. So ax1 and x2 is a two different frame, then can be plotted in one graph. Okay, so I don't have example here, but I can show you later on after you work with your tutors later on. So how we can combine. This is usually I think if you have a different data, right? So you want to show, if you share one x-axis, but you have different y, you want to show how it what they call it, the difference between it. So you have to have two frame. Yeah? So this one I show only one frame. Later on I will give you some example how to do the two frame for plotting. Okay, any question? Ada question? I hope you answer your question who asking this now.
Okay, Tangku, please.
Hi, Dr. Norhasliza.
Yes.
Can you hear me?
Yes, of course.
All right. This is my first time to know about the NumPy, which is NP. So my question is, when we need to insert the NP words in our equations, and what are the use of the NumPy, because it is my first time to learn about this Python programming.
Okay, so did I share the screen now? Okay, so question about NumPy. Okay, so the one I've mentioned previously about NumPy is NumPy we use to call some mathematical function. This is the example of mathematical function that we need to use. For example, if you want to call log, sine, cos, tangent, or pi, this must be called by NumPy. If not, the Python don't even know what is this. Okay, because the only things that people know the the mathematical function is you, right? But the computer don't know it. So what Python did is it create these packages so that it will call this mathematical function into your code. So when you want to do, for example, the one that I've shown you just now, for example, you want to write a sine to pi. You can see that we have a trigonometry here, we have and then we have pi, right? So when you want to write a code, if you write this like this, to multiply sine multiply 2 multiply pi, the Python don't understand this. So because this must be accompanied by this NumPy. Okay, so you can see that now I assign NumPy sine in the bracket to NumPy pi. So these are the mathematical library that will call the value. Because why? If you don't do this, the Python don't know where to take this value. And also, they don't know how to do the sign operation. Like your calculator, right? So calculator, you press a sign and they will produce, right? But in Python, they have additional step, which is NumPy to do this what I call special mathematical function. Okay.
All right, thank you, Doctor.
Okay, you will learn this later on with your tutor. Anything else?
Any question? Okay, Chandra, please.
Am I audible now?
Yes. Yeah.
Okay. Thank you for the occasion. This question has just comes to my mind. Earlier in the slide, you show us about classes of data types. Why we have to describe the data type np.array? Can we just use class list data type, just bracketed, just square bracket and nothing else?
A class
Yes.
For array, you mean?
Yes, for array. What's the difference between np array and list?
Okay, so NP array is when you have to deal with the scientific computational. Means that if you just want to read the data as is it, you can use class. So if you have to deal with arrays, for example, if you want to do regression later on with a set of your arrays, you have to call NumPy. Okay, because why? It will set you the size for your array. This array is also in the normal way we say it's a matrices. It's a matrix. Okay, so what is the size of your matrix? So for example, if you have a data 2 times 2, right? So if you just put class, how the deal with the scientific computing later on might not be cannot be done to calculate for example, you want to expand your matrices or you want to reduce it. So this is the way that why the NumPy is needed for this kind of operation. I think for class, I haven't used class a lot because class maybe they just print what are the type of your data set.
Okay, thank you. Thank you very much.
Anything else?
Questions again? Okay. No questions?
No question? Okay, so I move on to my one more slide. I hope I'm not taking too long before we move on to the next one. Okay. I stop share first. Okay, so I'm going to share you how we can deal with data in Python. I guess this is more interesting stuff for you to deal with it, because when we deal with astrostatistics, we deal with a lot of data, either observational data or simulation data. Okay. Right. So okay. So I move on to how to deal with data arrays. So this is tip and tricks of how to manipulate data. So in this introduction, I'm using modules what we call pandas. AstroPy I will introduce you later on. So pandas is another powerful module for you to handle what we call as a arrays as a data frame. Okay. So previously we don't have this kind of pandas module. So we have to read, for example, read CSV or something like that, row by rows, to deal with this Panda data frame. But by using Panda, everything being cut short by just one line. Okay, so the type of format can be handled by Pandas is including CSV. I think this is a lot being used in astronomy, a text file. We also can read Excel file. HD5 is, I think this is more like a figure or vector image. HTML, JSON, XML, this is usually people use in industry, so they use a lot of this. But I think for physicists or astronomer, they use a lot of this type of data. This also can handle .dat file, if you ask me. Okay, so how to read it is depends on what are the command that we needed. Oops. Okay, so here I show you how to read the data structure. So first of all, when we want to handle array, again, we have to call numpy. This is what some student asked just now, why we need to have numpy, because they want to handle this data array. And especially when we want to plot, all your data must be in terms of array. Okay, so when we have a file called data.txt, this is a normal text for data, and we have to call, you can see that I import these two libraries, numpy and pandas, and then I assign as a df. Df means that data frame. You can also put as data, no problem. Okay, so this is just to show what is the meaning by the data frame. Data frame equivalent to PD, the pandas, read FWF. This is specifically for the a text file. So this we have a fix with we read the external data. So if you have data in a different folder, you have to give proper path at this one. Okay. So from there we can, if you want to plot the data, we just import map.lib, and then we have to assign. You can see that this is the data without header. We don't know what is the value of x. This is just assigned x and y. Okay, so if you want to have a header and x and y, we have to assign header. So here we have data. We have to do the separation. Here is this is the automatic what they call separation of the column. If you have tab, you can put a slash t. But this is, I think, the most universal things that you can read almost any any column. And then because of our original data don't have header, I call it header none, and then I assign as S and Y. You can see that now the S and Y has been assigned. What is this 0 and 9? This is just that how data frame counted how many data that available in your text file. Okay. So this is just how the description of different file name and what are the reader and the writer that you need to know to read the the file. And from here, we can also, I just continue from there. So when you plot the data, you have to assign data frame for each individual, column. So from there, you can plot your data directly from the pandas. Okay, so this is very useful. For example, if you have a lot of data, so if you have a lot of data, you have to assign all the the names. If you have already the data here, you can see that now the data itself do have the header. So when you put 0 header, immediately it will recognize what is the header in your data. Okay, so the same thing like this. Later on, you can work out with your tutors. I just go through a bit. Okay, so if you have a large data set, for example, like this, Okay, so we have a star of CSV and all the value of temperature, luminosity, radius, this absolute magnitude, color, and spectral. If you open by using the normal editor in your Linux or your MacBook, you'll see you have the data like this. Very difficult to read, right? So what the Panda did is, you can either you can open to Excel or what they call numbers in OS. It can immediately give you nice what they call it column like this. Okay, so then we want to explore the data. What you can do is this one, I want you to do it with your tutor later on. The code is there and how you can manipulate the data and get the result later on. Okay, so then sorry, there's a spelling mistake. We have another one is AstroPy. So to read data in AstroPy, usually we use IO ASCII. This is .dat or .txt file. And for example, we have some data of GRB afterglow with this 3 column. And then comparable with the Panda just now, you just import AstroPy IO import ASCII, and then you read data, and then you will get like this. This is I think they use a CSV as the backbone for this AstroPy IO. Okay, so this is another way. If you don't want to use Panda, you can use AstroPy too. But both of them, you should explore both of them, especially if later on you're interested to work in industry later on, because they use a lot of Panda compared to AstroPy. But again, it is just a matter of preference of how we want to deal with data. Okay, so I think you can, I stop here and I want you to work out with what we call it, your tutors. Any questions so far? I also provide some how the info to read fit file, and you can work out, because this is I took from the AstroPy website, and you can try it your own after this. Okay, but I will be online if you have any question. So we already
any question? Yeah, Tengku, please.
Dr. Norhasliza, I have one question regarding to my problem, which is I need to open my data file via Python by using a module called DRMS. Is it DRMS module the package that we need to install? Later when we already got the Python package.
DRMS. Any astronomer can answer it.
Because the data file that I need to use via the Python need to have in a module DRMS. But DRMS module. But I could is it the package that we need to install our personally, or already installed by we install?
Can you type the name here, because I haven't used this what they call it package before. DRMS.
DRMS file module.
So any tutors here or anyone have used this one before? Anton or Ibnu?
I haven't have experience with this package.
Let me see what are the package DRMS module. Because the one that I've shown you in this lecture is the one, a very standard one that we have used a lot generally, right? So if you want to use what we call it a specific one, you have to really to read what are the files. Okay, so I see that there is DRMS here from the GitHub. Okay, so they say that DRMS module is provide an easy to use interface assessing HMI. Okay, so this one you have to pull from a specific repository called DRMS. So this is a non-standard what called Python module, actually, the one that you mentioned just now. So if you want to use this, you have to what we call it to pull the DRMS what they call it package to your Python module, and you have to do a bit what they call it testing or benchmarking before you can use it. This is what I can see from the manual here. So it's a bit specialized module that you have mentioned just now. Okay, so there is Arifin mentioned that is I think SunPy support the RMS data. It's data, isn't it? Arifin?
Yeah, it's a special data format for solar dynamics observatory data, if I'm not mistaken.
I see.
So SunPy support that. So it's a Python library as well, SunPy for solar physics especially.
So you have to install. Is it already in what they call Anaconda? You have to pull it from the GitHub, the SunPy.
It's already supported. I'll send the link.
Oh, okay, yeah, that should be fine. Great. Okay, so there's Udin already put some link here. Any question after this?
Yes, Rafi, please.
Yes, the Astropy, the bits file reading Jupyter Notebook is not provided in the GitHub link.
The Astropy, this one?
Yes.
Oh, okay, okay. Right, I will put it later on.
Okay, thank you.
Any other question? Let me push the code here. Is there any other question you want to ask?
Any more questions? Okay.
I hope everyone is still okay, not have a burning what they call it, a lot of things to digest today.
I want to ask some questions. Is it okay?
Okay,
sure.
Yeah, I'm curious because what library did you use, or you use both TensorFlow and PyTorch, or which one? I'm curious. Thank you.
Okay. It depends on the usage. Usually, generally we just use TensorFlow. But if you want to have a more, I think because if you read the manual, technically the idea is just the same. It's just that the method of preference, which one you want to use, and which are the specific application that you want to use. Okay, so this is another things that the method of preference. If another one is tomorrow, I will introduce you different one is a circuit learn. This is, I think, later on. Tri also use the same thing. I saw in his slide before. So it depends on what are the usage that you want to learn. Okay, so the idea is just the same, but the preference of individual depends on what are the modules that you want to use, and also what are the signs that you want to test. Another things that maybe many people don't mention from this morning what they call it session, I see that many don't mention about error analysis. Okay, so when we do scientific computing, one thing that we have to deal with, how good is your analysis? Okay, so when you have to know how good is analysis is, you have to cater what is the error from for example, if you have observational data and you want to do regression or machine learning later on, how big is the error with this your technique? So some people, maybe some astronomers don't really care about the error, but if you do a proper scientific computing, a huge error, if you do a lot of calculation, the error will be accumulated. When this error will be accumulated, for example, from what called multiplication, what you call division, and so on, the error will multiply, and in the end, either your calculation is correct or not. You have to compare, for example, an analytical result. Does the result being huge too far or not? Okay, so either you do a statistic or not. These are the things that we have to consider. Even the Gaussian also, they have a certain error that we have to know how much the indication that we have to constrain ourselves when we deal with the data analysis. Okay.
Okay, thank you, Dr. Liza.
All right, welcome. So any more questions? If no, we can move on to
one more question, maybe.
One
Daud?
more.
Okay. Okay.
No problem.
Yes. Okay, thank you. Am I audible?
Yes.
I have one question. Is there some sort of standard on how the code should be written. For example, like variable name, or maybe is it allowed to import NumPy as PD? Yeah, for example.
Oh, okay.
Yeah.
All right. So actually, one thing about Python is they don't really have what do you call it, some standard manual. This is if you are older generation like me. Okay, so we used to have C or Fortran or C++ with a standard manual what should be fulfilled, right? So, but in Python, it's kind of like a freeway. This is what I can see. For example, if you want to import numpy as, for example, something else, it doesn't matter. But when you import as something else, when you want to call numpy, you have to remember what are the import numpy that you assign. For example, what is your name?
Daud. Yes.
Daud. Okay. So for example, import numpy as Daud. Okay. So and then you want to do sign. So Daud dot sign X. So you have to make sure the name is same. This is just example. So this is how the numpy deals. Sometimes people don't really put as something. They just import numpy and then numpy sign X also can be done. Why people put short form? So if you write a long code, the short form will be very useful. This is the way how we do coding. Another thing that you say as a variable. Okay, so in Python, there is usually people who are do coding. Actually, people have done coding in other language before, so they always follow whatever their preference. For example, you want to put some luminosity equivalent to your data. You can do that because in Python they don't have constraint on how many number of character it can handle. This is one thing about Python. But if you use other language, they have constraint. For example, certain language, you have to assign, for example, only 5 or 6 variable equivalent to what. Okay, so in Python, it's don't have this regulation, but it must be in one word. Okay, it cannot be separated. It must be in one word. Okay, so and it cannot cater bracket. If you put bracket, for example, luminosity bracket L, so it will see that there is some operation, not a variable. That is the things that how Python works. Okay.
Okay. So there is no strict standard, even for the academic purpose, yeah.
Well, it depends. If you ask me, when I teach student, I put some standard, so that what they call it, student at least they follow the first regulation, and after that, when they have the idea how to do it, then you can do by your own. Because especially for those who don't have any experience doing programming, you have to say something first. You have to set some regulation. If not, there will be chaos everywhere. That is my experience dealing with the student. Yeah, okay. If not, because for example, if you want to share your code with other people, we have to understand that how people read your code, right? So you cannot create the code only you can read, but others cannot be read. For example, in astronomy community, right? We share codes. When we share codes, for example, one day you have student, so you have to write a code that later on your student and then the student of all your students can read your code. So if you do some non-standard coding or programming, in the end your code will be not usable later on. Okay, so this is one things that I always mention to students, make sure your code is readable, and that's why comments is important. If you want to put some fancy variable, doesn't matter, but please put the comment for that one. Okay.
Okay. Thank you. Thank you very much.
Okay, no problem.
Okay, maybe we can next one. Breakout room or
yeah, we can go to breakout room now. So what the plan is, I hope that all the students what they call it, try to do all the exercise and let me know if you have discovered, especially the one that I mentioned for the data and how you can do, for example, the AstroPy here, and also how you do this this star data. I already give the nice what we call dataset.ipynb, and I want the student to understand how the code run. Okay, I hope that the tutor can help in the student understanding the code here. Okay. So if any question, we can move on to the slide, or you can move on to the main room. It depends on what the best thing the organizer thing.
Okay, Nimas, can we going to the breakout room for each group?
And then I upload GitHub, so it's I work in a different machine, so it's a bit everywhere is here and there. Sorry about that, but it's really easy to edit. You just rename the dataset as data to read all the data I've given in the Python. So any questions so far? Anyone? If I also provide one tutorial, but they will be a bit advanced things to do. Anyone who would like to ask anything before we stop our session or something? Feel free to ask anything.
You can give also homework to the participant if you want.
Hi, Dr. Liza.
Yes.
We just encountered the problem regarding the Google Colabs.
Mm-hmm.
Maybe Eston, can you share us your screen maybe? Yeah, he just tried to run to read the file DRBF ago, but
oh, okay. So where do you put the data? Okay, so in Google Colabs, you have to save the data in your drive and then call from your drive.
Yes. Okay. I already do it. I download the data to my drive, and after that I upload to Google Colab. Use the task, the syntax like this.
Mm-hmm.
And when I call the data, the error.
So you have to rename. There is a bracket too, yeah. So there is you have to remove that because the name is okay. Move okay. So let us try. So usually in what Google Colabs, you have to put a bit longer path here for this one. I think that tries it is give error or not. Can you run again?
Still error.
Yes. This one you have to give the path to your Google Colab. To your Google Drive. So it should be in your My Drive / where is the place that you put your data.
Oh.
Okay, so you can open your Google Drive and check where is the location of the data in your Google Drive.
Ma'am, sorry to interrupt. Maybe it's better to mount your drive before using anything from your drive.
So I check this one is.
Yeah, because mounting will work. If you want, once you mount your drive to this Colab, so you can access any file in that particular folder from your drive.
Yes, correct.
Better you should mount your drive and then use this file directly.
Okay, I will try it.
Yeah, because the problem is Google Colab didn't find your data actually. That is the only things. So either you can mount it or you have to put the full path if you don't mount it. You can do it 2 ways.
Thank you, Miss.
Okay. Anyone else want to ask question?
Yes, Chandra, please.
Yes, ma'am. I encountered some problem in the file grb_afterglow.dat. There's some strange symbol in the first two rows and the last row. It makes I cannot read the file in AstroPy.
Yes, you have to what we call it rename the data set to data first, because if you download from directly from GitHub, I'm trying to edit the GitHub. So when you rename, can you show me what is the error?
Okay. This is the file. After I open it, there is these two rows. Actually, there's no hashtag here.
Oh, so you have to remove all those header there, I think, because you download it. So you have to delete everything. No, hold on. You have to delete this BP until the web resources, because that is the header that will prevent the reading. Yeah, delete everything. Delete the end. Yeah, and then you save it. Save it. You look at down. Is there?
And this also delete?
Yes, yes. And then there is, sorry, hold on. There is a hashtag down there. It will.
Yes, that's right.
Let's see.
Okay, thank you. Thank you very much, man.
Okay. Anything else?
Anissa, okay, please.
I just want to ask about which better if laptop was have 2 GB capacity RAM for running code between Google Collaboratory or Anaconda or Jupyter.
Okay, so this question, Anaconda is a bit too heavy for 2 GB. The another option is you can use Miniconda. I didn't put the link here. Maybe the tutor will help you to install. Miniconda is the lighter version of Anaconda. Okay, so and also if you feel difficulty to install, I guess Google Colabs is another option, the best one you to do for this tutorial. But you have to know how to load the data into your drive before you want to do for the exercise for the data.
Okay, thank you.
So do you have a stable internet connection?
Yeah. Sorry, I lost connection.
Oh, if you have stable connection, Google Colabs will be very great to use. But if you don't have stable internet connection, it will take some time to load the code itself to the drive.
Okay.
Okay, right.
Okay, thank you.
Anything else? Want to ask?
No more question? Okay, it's 1 minute to 15, Liza. Okay, I think we are at the end of this session.